everyone, welcome to Geology. Today we'll talk about petrology, but of course, before diving in, first let's define petrology. Petro, which means rock, and logy, or the Greek word logos, which means studies, will already give you an idea on what branch of geology we'll discuss today. The study of rocks is known as petrology. It involves rock composition, textures, and structures, their occurrence and dispersion, as well as their genesis that relates to geologic processes and psychochemical circumstances. To study the formation of volcanoes and their magmatic sources, petrology is used. It also helps the study of the evolution of continental crust, the accessory minerals, and the geological processes that occur on the other planets.
We will now give a short definition of petrogeny and petrography. Petrogeny or petrogenesis is a branch of petrology dealing with the origin and formation of rock, while petrography is concerned with the description and classification of rocks.
After giving definition to petrology, we'll now dive into the different kinds of rocks.
We will tackle about igneous rock. So what is igneous rock? Igneous rock from the solidification of one molten rock material. When this mass melt is found underground penetrating other rocks, it's called magma, and the solidified rock is termed intrusive. By contrast, molten material has erupted into the Earth's surface is named lava, which cools into the geologists called extrusive or volcanic rock. Some igneous rock are formed below Earth's surface. Some form on or above Earth's surface. We describe these two basic types as intrusive igneous rock and extrusive igneous rock. A subvolcanic rock, also known as hypabyssal rock, is an intrusive igneous rock that is emplaced at depth less than 2 km or 1.2 miles within the crust, and has intermediate grain size and often purpuritic texture between that of volcanic rock and plutonic rock. Subvolcanic rock includes diabase, also known as dolerite, and purpurite. Extrusive igneous rock. Extrusive igneous rock erupt onto the surface, where they cool quickly to form small crystals. Some cool so quickly that they form an amorphous glass. These rocks include andesite, basalt, dacite, obsidian, pumice, rhyolite, scoria, and tuff. What is the difference between intrusive igneous rocks and extrusive igneous rocks? The difference between intrusive and extrusive igneous is that intrusive rock is one that forms when magma cools within Earth. Extrusive igneous rock is one that forms when lava cools on Earth's surface. Now, let's talk about concordant igneous rock. A concordant igneous rock body runs parallel to the pre-existing bedrock. Laccoliths and seals are examples of concordant igneous rock bodies. The number one example is seals, sheet intrusion that form between strata in a layered rock mass. They may be parallel, inclined, or horizontal depending on the attitude of the strata in which they are intruded. Even if they came to stand vertical by tectonic movements, as long as they lie parallel to host strata, they are still seals. Seals vary in thickness from a few centimeters to several meters, but they are thin compared to their length and width. If several seals are intruded parallel over and below one another, like a pile of pancakes, they may develop into one of the other form. There are 4 types of seal. The first one is single seal. A simple seal is the product of a single intrusion. Second one is multiple seal. A multiple seal is formed by two or more intrusions. The third one is composite seal. A composite seal is composed of more than one rock type position between older layers of rock during more than one intrusion episode. The fourth one is differentiated seal. Exceptionally large, sheet-like injections of magma, segregation of minerals formed at various stages of crystallization into separate layer of zones. Lopolith. A lopolith is a large layered igneous intrusion that is distinguished by the convex downward ball shape of its floor and whose top can either be flat or convex down. Lopolith are intrusion of igneous rocks with ball-shaped floors and either flat or ball-shaped tops. Lopoliths are usually mafic and they are characteristically much larger than laccoliths.
So another type of rock is laccolith. Laccolith in geology is any type of igneous intrusion that has split apart two strata, resulting in a dome-like structure. A laccolith is often smaller than a stalk, which is another type of igneous intrusion. And usually, it is less than 16 km or 10 miles in diameter. Stratum or strata is less than 1 cm or 0.4 inch in thickness. They can be contrasted with seals, which are sheet-like intrusions oriented parallel to the bedding of the enclosing rock. So the thickness of laccoliths ranges from hundreds of meters to a few thousands of meters. The floor of the structure is usually horizontal. Seals, or the sheet, is the flat intrusions of igneous rocks that forms between pre-existing layers of rock. The stratum, or the strata, is a sedimentary rock layer bounded by two stratification planes, or the layering that occurs in the most sedimentary rocks, or what you call the bedding. The latter being produced by visible changes in grain size, texture, or other diagnostic features of the rocks above or below the plane. So, the next topic that I will tackle about is the discordant. Discordant is a coastline that occurs where bands of different rock type run perpendicularly to the coast. The differing resistance to erosion leads to the formation of headlands and bays. So, in geology, a body such as a dike or a vein that cuts across primary rock structures such as the bedding. So, a discordant is a arrangement of rock strata in which the older underlying ones dip at a different angle from the younger ones that are overlaying too. So, the next is batholith. Batholith is a large body of igneous rock formed beneath the Earth's surface by the intrusion and solidification of magma. It is commonly composed of core-grained rocks, granite, or granodiorite with a surface exposure of 100 square kilometer or 40 square miles or larger. A batholith has an irregular shape with sidewalls that incline steeply against the host rock. So most batholith intrudes across mountain folds and are elongated along the dominant axis of the range. So faulting and contact metamorphism of the enveloping rock near the batholith is also observed. So if you picture out what a batholith is a type of igneous rock that forms when a magma rises into the Earth's crust but does not erupt on the surface. So the next is the dike, or also called the geological dike. So it is a tabular or sheet-like igneous body that is often oriented vertically or steeply inclined to the bedding, or the pre-existing intruded rocks. So it is similar to a bodies that are oriented parallel to the bedding of the enclosing rock that are called sills. So sills, or the sheet flat intrusion of igneous rock that forms between pre-existing layers of rocks. So a dike is a set of composed of several parallel dikes. When the number of dikes is larger, the term dike swarm is used. So dikes have a wide range of rock compositions. So in geology, a dike is a large slab of rock that cuts through another type of rock. So a geological dike is a flat body that cuts through another type of rock. So the next one is the volcanic neck. So a volcanic neck is the throat of a volcano and consists of a pipe-like conduit filled with hypabyssal rocks. So a volcanic neck is the solidified magma trapped inside a volcano. So after a million years, the softer outer layer of the volcano erodes and all that remains is the volcanic neck. So if you picture out what is a volcanic neck, it looks like the top of a toothpaste tube but made out of a solid rock. So the next one is a vesicular. Vesicular is a fossil bubbles, a rock that looks like a Swiss cheese that has a vesicular texture. So vesicular range in shape from spherical to elongated and in size from 1 millimeter to more than 1 centimeter. So it is commonly known for a basalts. So basalts are most commonly a vesicular. So vesicular have been partly or filled with quartz, chalcedony, opal, calcite, epidote, zeolites, or other minerals. So vesicles are the small holes left behind after lava cools and turns into a volcanic rock. So vesicular help geologists understand the cooling history of exclusive or the volcanic rocks because lava contains large amounts of dissolved gases that are released as the lava hardens. The next one is the amygdaloidal. So amygdaloidals are simply vesicles that have been filled with a secondary mineral long after the flow cooled. So amygdaloidals such as secondary minerals are commonly white, so such as the quartz, calcite, or the zeolite. So a secondary mineral such as the amygdaloidal is one that is formed after the rock originally formed. So amygdaloidal is also a basalt but different in colors. So a amygdaloidal is a dark colored volcanic rock formed from a magma of basic composition erupted on the Earth's surface. So amygdaloidals are magmas generally contain dissolved gas which can form bubbles in the magma as the pressure is released on the eruption. So these bubbles can get trapped in and solidify the rock. So the next one is the columnar. Columnar is a jointing forms in lava flows, sills, dikes, ignimbrites such as ash flows stuffs, and shallow intrusions of all compositions. So most columnars are straight with parallel sides and diameters from a few centimeters to a 3 centimeters. So some columns are curved and vary in width. Columns can reach heights of 30 meters. So most columns tends to have 5 or 6 sides but have as few as 3 and as many as 7 sides. So the columns may form sets. Straight, regular columns are called colonnade. So, irregular fractures, columns, are called entablature. So, the formation of columns due to the development of vertical sets of joints through contractions of lava. So, the last one is the sheet. So, sheet is a horizontal slices developed on the massive igneous rocks due to one set of well-defined joint is called the sheet structure of igneous rock. So, the sheet is a plate-like structure developed in rocks due to the development of different sets of joints.
Flow. Flow structure in the igneous rock are formed in the fluid stage, but plastic flow occur in the softened rocks adjoining some intrusion, and diaporpic effect occur in the plutons, originating by the transfusions. Both fluid and plastic flow have, therefore, to be considered under flow structures. Flow structure and transport in the submerged aquatic canopy are influenced by two scales of turbulence. Canopy scale turbulence caused by flow stability at the canopy's top, and element scale turbulence caused by flow stability beneath the canopy. The canopy drag, which determines the length scale of penetration from the top of the canopy, limits the penetration of canopy scale turbulence into the canopy. The displacement thickness for the logarithmic velocity profile above the canopy, as well as the decay of stress-driven flow beneath the canopy, are both determined by this length scale. Furthermore, it divides the canopy into two discrete travel zones. Canopy scale vortices control vigorous vertical transport and high level of turbulent diffusion in the upper canopy because of the smaller element scale turbulence. Movement in the lower canopy is substantially slower. Pillow. Pillow basalt is a volcanic igneous rock that formed when a lava of basaltic composition erupted underwater. The rapid cooling of the lava by cold water of all sides formed the pillow-shaped bodies, which can then break open and extrude more of the hot lava from inside. The rapid cooling also creates pillows that are composed of volcanic glass on the outside and that have very tiny, almost visible crystal on the interior. Pillow basalt typically form at the volcanoes at mid-ocean ridges or at oceanic hot-spot volcanoes, such as those that form the Hawaiian island. Basalt form that truss all of the Asian basins and is therefore the most common rock in the earth crust. Equigranular. All those textures in which majority of constituent crystal of a rock are broadly equal in the size are described as equigranular textures. In igneous rock, these textures are shown by granites and felsites, and hence are also often named as granitic and felsic textures. The elements in granitic textures are either all coarse grain or medium grain, and the crystal have hederal or subhederal outlines. In felsic textures and grains are primarily small crystal, although they generally have excellent outlines. As a result, felsitic textures are equigranular and plan idiomorphic. Orthoperic texture is a form of equigranular texture that falls somewhere between granitic and felsic. Individuals' grains are fine but not microgranular in size. In equigranular igneous texture, in which the majority of constituent minerals show marked difference in their relative grain size, are grouped as in equigranular texture. Porphyritic and poeclitic texture are important examples of such textures. Porphyritic and poeclitic textures are good examples of this type of texture. The porphyritic texture is distinguished by the presence of a few prominently big crystal penoris contained in the fine-grained ground mass of matrix. Depending on the size of the penoris, the texture is sometimes classified as a megaporitic or microporitic. Porphyritic. Porphyritic texture is an igneous rock texture in which large crystals are set in the finer grain or glassy ground mass. Porphyritic textures occur in the coarse, medium, and fine-grained igneous rock. Usually, the larger crystal known as penoris form earlier in the crystallization sequence of the magma. Serrates refer to the porphyritic texture with a constant change in the crystal size. Porphyries are the type of hypabyssal rock having porphyritic textures. Poikilotic. Poikilotic texture refers to crystal. Typically, Petrology in the igneous rock which contains small grains of other mineral. Poikilotic texture is extensively employed in igneous rocks to identify the crystallization order. If one mineral is surrounded by another, the encased grain must have crystallized first. This may be true on all occasions, but is not always. Ophitic. Ophitic texture is the association of plant-shaped euhedral crystal of plagioclase grouped radially or in the irregular mesh with surrounding or external large adhedral crystal of pyrocene. It is characteristics of the common rock type known as diabase. Random pyrolase lands are encased by pyroxene or olivine in the optic texture, which is the form of poikilotic texture. The texture is subhetic if the plagiolase is bigger and closest to the ferromagnesian mineral, and the land typically impinges on the another to form acute angle. In basaltic rock, the transition from the intergranular to subohetic to optic texture is due to slower cooling and nucleation rates. This textural sequence is often found in the diabasic or the doleritic rock or bastic dikes from the chilled surface to depth, or in the basaltic flow from the chilled surface to depth. The interstitial materials between plagioclase slats may be equivalent to glass and form interstellar texture if the cooling rate is very quick. Pegmatic or intergraph. A graphic texture is an igneous rock texture in which an intergrowth of two minerals has the appearance of runic writing. Rocks containing abundant graphic textures can be described as granopyric. Simultaneous crystallization of phases from a silicon melt in the presence of a hydrous fluid phase has been proposed as the source of graphic textures. Vesicular. Vesicular textures refer to the volcanic rock that contain holes called vesicles that were formed by the gas bubble in the lava. The name of this igneous rock is scoria. The texture is vesicular. Vesicles arise as the gas bubbles escape from the cooling lava.
Sedimentary rocks are type of rock that are formed by the accumulation or deposition of mineral or organic particles at Earth's surface, followed by cementation. Sedimentation is the collective name for processes that cause these particles to settle in place. Clastic deposits. A clast is a fragment of geological detritus, chunks, and smaller grains of rock broken off other rocks by physical weathering. Geologists use the term clastic with reference to sedimentary rock as well as to particles in sediment transport, whether in suspension or as bed load, and in sediment deposits. Chemical deposits. The most common chemical sedimentary rock by far is limestone. Others include chert, banded iron formation, and a variety of rocks that form when bodies of water evaporate. Biological processes are important in the formation of some chemical sedimentary rocks, especially limestone and chert. Mineral deposits form during the accumulation of sediment on the bottom of rivers and other bodies of water. According to their place of formation, they are divided into river, swamp, lake, sea, and ocean deposits. Organic deposits. Organic-rich sedimentary rock deposits are collectively referred to as fossil fuels because they consist of the undecayed organic tissue of plants and animals preserved in depositional setting characterized by a lack of free oxygen. Stratification and lamination. Stratification, the layering that occurs in most sedimentary rock and in those igneous rocks formed at the Earth's surface as from lava flows and volcanic fragmental deposits. The layers range from several millimeters to many meters in thickness and vary greatly in shape. Thus, lamination consists of thin units embedded or layered, sequenced in a natural rock succession, whereas stratification consists of bedded layers or strata in a geological sequence of interleaved sedimentary rock. Graded bedding. In geology, a graded bed is one characterized by a systematic change in grain or class size from one side of the bed to the other. Most commonly, this takes the form of normal grading with coarser sediments at the base, which grade upward into progressively finer ones. Such a bed is also described as fining upward. Graded beds form when a steep pile of sediment on the sea floor or lake floor suddenly slumps into a canyon or off a steep edge. As the sediment falls, water mixes in with it, creating a slurry of sediment and water that flows quickly down a sloping bottom. Current bedding. Sedimentary structures include all kinds of features in sediment and sedimentary rocks formed at the time of deposition. Sediments and sedimentary rocks are characterized by bedding, which occurs when layers of sediment with different particle sizes are deposited on top of each other. The condition of having laminae lying transverse to the main stratification planes of the strata occurs only in granular sediments, also known as cross-lamination or cross-stratification. Marks are sedimentary structures and indicate agitation of water, current or waves or wind. Ripple marks are ridges of sediment that form in response to wind blowing along a layer of sediment. Sedimentary rocks are formed from deposits of pre-existing rocks or pieces of once living organism that accumulate on Earth's surface. If sediment is buried deeply, it becomes compacted and cemented, forming sedimentary rock.
Mud cracks. Mud cracks form in a very fine clay material that has dried out. As the moisture is removed, the surface will split into cracks that extend a short way down into the mud. These cracks form polygons on the surface of the mud. The top of the bed has the widest distance between the polygons, and the cracks taper downwards into the bed. If later sediments come and fill in the cracks and are preserved, the relationship of the bed of the tapered feature will be saved. The tip of the cracks are always oriented downwards, pointing to the bed based on the older part of the formation. How old they can be. We're looking down onto the top of the bed, and now that anything that is found above the surface will be How old they can be.
We're looking down into the top of the bed and know that anything that is found above the surface will be stratigraphically younger than the surface at which we are looking. Next is the track and trails, rain prints. When any living being passes over soft sediment, it will leave an imprint of its passage. The footprints of a tiger, tail drags of a crocodile, or pointed depressions from a crab's legs. These impressions often are filled in with sediments and preserved as trace fossils. A trace fossil is indirect record of a organism having once existed. It is not a bone or tissue of the once living being, but an artifact of the organism's life on Earth. One particular type of trace fossil, a footprint, can readily show which is way up by seeing in which way the bottom of the foot is relative to the top of the foot in the impression. The texture of sedimentary rocks. First one is the clastic. Clastic sediments are predominantly clay minerals and quartz particles, with minor amounts of feldsparks, micas, and heavy minerals. Porosity results from the space between the grain particles that is not filled with cement or clay. Porosity is usually in the range of 10% or 30%, depending on the grain sizes, compaction, and the amount of cement present. Between the pores, permeability, which is the property that permits fluid to flow through the pores, is controlled by the amount of cement, the degree of compaction, and the magnitude and the variation of the grain sizes. Next is the bioclastic. Bioclastic sediments is a term used to describe carbonate-rich sediments consisting of fragments, shells of dead organisms. On the continental shelf, we find bioclastic sediments with a high content of the remains of the stony corals. These sediments form mounds and ridges in many places, which may be associated with living corals. Sediments or the bioclastic sediments can vary in grain size, from clay to blocks and the various areas of origin. Locally deposited bioclastic sediments found near coral reefs most often consist of corals and blocks of dead corals, but these sediments may contain a significant amount of clay, silt, and sand that has been transported with the ocean currents. Maps of bioclastic sediments do not contain information about the proportion of living and dead organisms, nor there is information about the species types. Bioclastic sediments are mapped using the acoustic methods, the bathymetry, and the backscatter provided from multi-beam, echo sounder, and sonar, sediment sampling, and video surveys. Crystalline. The crystalline rocks that form the hinterland deformation belt structural province originated both as accreted terrains and as native North American rocks. As such, intrusive granitic rocks also play a prominent role. Native North American rocks include the crystalline shield and deformed metamorphic equivalents of the Precambrian sedimentary volcanic rock succession, slope rises rocks, and in few areas, rocks of the Myogeocline. These rocks form the narrow, native North American belt, which encompasses the western Blue Ridge and the Green Mountains of Vermont. Shirt breaks with a conchoidal fracture, often producing very sharp edges. Early people took advantage of how shirt breaks and used it into fashion cutting tools and weapons. Shirts and flints are names used for the same material. Both are variants of chalcedony. How does shirt form? Shirt can form when microcrystals of silicon dioxide grow within soft sediments that will become limestones or chalk. In these sediments, enormous numbers of silicon dioxide microcrystals grow into irregularly shaped nodules or concentrations when dissolved silica is transported to the formation site by the movement of groundwater. If the nodules or concentrations are numerous, they can grow large enough to merge with one another to form a nearly continuous layer of shirt within the sediment mass. Shirt formed in this manner as a chemical sedimentary rock. Some of the silicon dioxide in shirt is thought to have a biological origin in some parts of the ocean and in shallow seas. Large numbers of diatoms and radiolarians live in the water. These organisms have a glassy silica skeleton. Some sponges also produce spicules that are composed of silica.
Metamorphic rocks. Any of a group of rocks formed by the change of previous rocks as a result of changing environmental circumstances such as temperature, pressure, and mechanical stress, as well as the addition or deletion of chemical components. Foliated. Foliation is a term used in geology to describe repeated layers in metamorphic rocks. Each layer can be as thin as a piece of paper or as thick as a meter. The word folium derives from the Latin word folium, which means leaf, and alludes to the planar sheet-like form, shearing forces, or differential pressure causing it. Types of foliated metamorphic rocks include slate, schist, and gneiss. Non-foliated. Non-foliated metamorphic rocks frequently lay platy minerals like micas. They lack foliated textures. They are frequently caused by touch or regional metamorphism. Marble, quartzite, greenstone, hornfels, and anthracite are among examples. Structures of metamorphic. Metamorphic rocks are frequently linked to Earth's large-scale structural characteristics, kilometers to tens of kilometers. Folds, naps, and faults of various geometries are examples of such features. Porphyroclastic. Porphyroclastic is a clast or mineral fragment surrounded by a ground mass of fine-grained crystal in a metamorphic rock. Porphyroclasts are pieces of the original rock that formed the ground mass before dynamic recrystallization or cataclasis. This indicates that they are older than the surrounding ground mass. Next is moculus. The production of large-sized crystals termed porphyroblast within a otherwise fine-grained rocks as a result of thermal metamorphism or argillaceous. Rocks like shale is distinguished by a speckled look of a rock. Schistose. Schistosity is a foliation mode that develops in certain metamorphic rocks as a result of platy and lath-shaped mineral components aligning parallel. It shows a high degree of metamorphism, that is changes caused by high temperature, pressures, and deformation. Granulous. A metamorphic rock's granulous structure is caused by the prevalence of equidimensional minerals such as quartz, feldspar, pyroxene, calcite, and others. Gneiss. Gneissic rocks are typically medium to coarse foliated. They have been largely recrystallized but no longer contain considerable amount of micas, chlorite, or other platy minerals. Granite, gneisses, diorite, Diorite gneisses, and other gneisses are metamorphosed igneous rocks or their equivalents.
I will discuss about the physical classes of rocks. First physical classes of rocks is stratified rocks. Stratified rocks are opposite of unstratified rocks that compose of layer structure that are connected because of stratification and process of cleavage or binding planes. The layer of stratified rocks can be as thin as 1 centimeter and as thick as 1 meter or above. Stratified rocks is a layer of structures formed by the deposition of sedimentary rocks. Changes between strata are interacted as the result of fluctuations in the intensity and persistence of the depositional agent. Example, currents, wind, or waves, or in changes in the source of the sediment. Sandstone is a sedimentary rock composed mostly of quartz sand. It's a widespread form of sedimentary rock that can be found in sedimentary basins all over the world. Slate is a fine-grained, foliated, metamorphic rock that is created by the alteration of shell or mudstone by low-grade regional metamorphism. They've been used as a building stone for centuries because of their strong viscosity, which makes them a great roof tiles. They've also been used as chopping boards, tombstone, and thermal electric insulators, as well as writing slates, blackboards, or notepads. Limestone is a sedimentary rock composed primarily of calcite and calcium carbonate mineral with a chemical calcium carbonate. Chemicals sedimentary process of limestone, such as calcium carbonate precipitation from lake or ocean water, can also cause it to form a carbonates or calcium and magnesium. For instance, we will call as dolomite. Foliated rocks. Foliated rocks are formed in a layered structure that has been induced under lateral pressure. These rocks have a tendency of splitting along a plane of definite direction, only which is not necessarily be in a parallel direction to each other. Foliated rocks is a metamorphic rock that has distinct layers, textures, and patterns. Examples of foliated rocks are included gneisses and schist. Gneisses is a high-grade metamorphic rock, meaning that it has been subjected to higher temperature and pressures than schist. Gneisses, bands, and lenses of different mineral content help to identify it. Some of these bands or lenses contain interconnected granular minerals rather than composition. It's in these banded appearance and textures. His is a foliated metamorphic rock made up of plane-shaped mineral grains that are large enough to see with an unaided eye. Next is the second physical classes of rocks, is the unstratified rocks. Unstratified rocks are abundant in nature and are frequently found alongside stratified rocks, but not stratified rocks. Throughout their entire body, they have a similar structures. Stratified rocks cover most igneous rocks and sedimentary rocks. They possess crystalline and compact grains. The most common example of unstratified rocks are granite, trap, quartzite, and basalt. Granite is a light-colored igneous rocks with grains large enough to be visible with the unaided eye. Next is trap. Is a name used in the construction industry for any dark-colored igneous rocks that is used to produce crushed stone. Lastly is the basalt. Basalt is a common gray to black volcanic rock. Basalt is an igneous rock composed of mainly of flangate clays and pyroxene minerals. It most commonly forms as an extrusive rock, such as lava flow, but can also form in small intrusive bodies, such as an igneous dike or a thin seal.
This ends our lesson on petrology. We hope you learned a thing or two from us. Thank you very much.